All right, so we have a curve. In quadrant 1, it is rotated around the x-axis. And so when we're thinking about this curve, we're thinking about something that looks, sort of, it starts at 2 and it's going to go down towards the x-axis. It's going to approach it pretty fast. 1 over x to the 5th, that approaches the x-axis pretty darn fast. If we were finding the area under that curve, it would be finite because the power in the denominator on that x is bigger than 1. And we've seen that that creates a curve that goes to the x-axis fast enough that you would have finite area. But that's not what we're doing here. We are rotating this curve around the x-axis, creating a horn-like object, which we did a couple of examples called Gabriel's horn, and this is similar to that. Now, we are going to be using the disk method here. If we imagine a point on the x-axis, we are going to create these little disks in here. And we know that the area of a disk is pi r squared. And because we are using a vertical element here, vertical integration element, we are going to be integrating with respect to x. And so for us, our area is going to be pi times the function squared. We're integrating with respect to x, so we have to have all the only variable we can have in here is the letter x. So there is our area function. We've learned that integrating this continuous area function is going to give us the volume. So the volume will be the integral from 2 to infinity. Let's see, when we square this, we get 1 over x to the 10th dx. And now this is an improper integral, right? We see right there that this is an unbounded region over here. So the next word that we write down is limit. The pi can factor out to the front. So we'll say the limit as b goes to infinity. And we're going to create a definite integral over here. And I'm going to write that as x to the negative 10. So we can do the power rule. And that definite integral, so this right here is a definite integral, and that's going to create a function of b. And then we're going to take the limit of that function of b as b goes to infinity. We add 1 to the exponent, getting negative 9 divided by the new exponent from 2 to b. So then we have pi limit. And we can factor out that negative 9, so maybe I'll put a negative and an over 9 here. And let's rewrite that, or at least think about it, as 1 over x to the 9. So it's going to be 1 over b to the 9 minus 1 over 2 to the 9. And this limit is as b goes to infinity. Okay. Well, this constant over here, this is just a number, right? A constant goes to itself. There's no b there, so that's just a constant. The limit of a constant is itself. Now over here, that b is in the denominator, and it's going to infinity, which means b to the 9th is going to infinity, which means this fraction is going to 0. So that fraction is just going to be gone because it approaches 0. So we end up with negative pi over 9 multiplied by negative 1 over 2 to the 9. And that will be our answer. So negative times negative is positive. And then we're going to have 9 times 2 to the 9th. And when we simplify this, 2 to the 9th is 512. And if we multiply that by 9, we get 4,608. So that'll be our final answer, and that is the volume of this horn.